Yes, good morning. My name is Abid Nadeem, and I will today deliver the lecture on planning and scheduling. Okay, so I'm going to share my screen. Can you see the screen?
Not yet. Yes, you can see.
Okay, good. So this is the topic number 2 of this lecture, planning and scheduling. It is from chapter number 16 of your textbook. I just uploaded its PDF, so you can see it from your Moodle accounts. Okay, so planning and scheduling topic is a very important topic in construction management. It is one of the main activity in a construction project. Without that activity, the success of any construction project cannot be guaranteed. And can you hear me well? Is
Yes,
the
we
volume
can.
okay? All right. So in this case, first of all, let's have some introduction. In the introduction, some planning must be done in order to perform any function with the minimum of wasted time and effort. So you need to do some planning. If you do any work in your life other than your construction project, or even in the or not only just the construction project, but in your other activities, some planning is needed. So planning actually can help you reduce the wastage of your time and effort. So general example can be, for example, getting even we do some sort of planning for doing our day-to-day work, such as going to work on time or constructing $1 million building. So these are the two extreme examples. Okay, so getting to work on time is a daily routine, but even for that daily routine, you have to do some sort of planning. But or on the other hand, if in your professional life you will be working on a multi-million-dollar building project, definitely there will be some plan, or you have to make some schedule as a result of this plan later on. Okay, so a schedule is a time-phased path. So this is the simplest of the definition of the plan, okay, of the schedule. A schedule is a time-phased plan. That means if you include the time dimension, in the plan, and then say that if you do certain kind of activities at certain times, when some activity will start, when some activity will finish, then that plan will be the called as the schedule. Scheduling is utilized from master planning through facility construction to facility operation and maintenance. So this sentence says that scheduling, or in the other hand, or in the back end, planning is included in almost every phase of the project, starting from the master planning through the actual construction, or later on for the operation and maintenance. For every aspect, for every phase of the project, planning is needed. Normally, when we talk about the planning, we just talk about the planning in the construction, but it is not a complete statement. Okay? So the scope of planning includes the whole project life cycle. in construction phase itself, schedules are useful for a number of purposes before starting a project and after completion of the project, as well as during the actual conduct of the construction project. It is the same sentence as before, but with some more limitations. That means if we just talk about the construction project itself, so the planning may be needed before the start of the project, during the duration of the construction project, or for the conduct of when the construction has completed. Okay. So for every phase of the construction project, the planning may be needed. Okay. And for each type of plan, some of the schedules will be made. So what is the purpose of planning and scheduling before starting, during construction, and after completion of the construction? So before starting, what is the purpose? Okay, it provides an estimate of the time required for each portion of the project, as well as for the total project. So this is obvious. So with the help of planning and scheduling, we can know that what each part of the activity will take, and then how long it will take for the project to complete. So this is quite obvious. It establishes the planned rate of progress. It not only tells that how much total time certain activities or certain part of the project will take, it will also tell that from when to when. Okay. So for example, if an activity can take, say, 2 days to complete, okay, but from when to when, whether it is coming at the beginning or coming at the end. So, and how long, within these 2 days, how much work will be performed in the first day, how much work will be performed in the second day, okay, or for a certain activity which has a longer duration. So then we can, it also, the planning and scheduling will also establish whether the rate of work performed is linear, or it will follow some other pattern as well. Normally, we assume a linear progress of the work for simplicity purpose. For longer activities, for smaller activities, there are some other distributions as well. So anyway, if we go deep into the planning and scheduling, we can also have some idea about the planned rate of the progress of the work. It forms the basis for managers to issue instructions to subordinates. So planning and scheduling is a very useful tool for the project administration. So for example, the planning and scheduling flows from the upper level of management to the lower level of management, or to the line managers or the workers. So the managers can issue the instructions to their subordinates based on those plans, because the managers will be those who will be responsible for creating those plans. They will have the overall big picture of the project, and then they can tell about certain components of the projects which they will assign to their subordinates. Okay, so they can give the instructions to the managers. It establishes the planned sequence for the use of personnel, materials, machines, and money. So before the starting of the project, it is very important to know that when do we need certain personnel, when do we need certain materials, when do we need certain machines, and of course, for all those things to deploy some capital in the form of money or currency is needed. So when do we are going to spend those resources, direct or indirect resources? Okay. Now, everything which has been discussed before, which is needed in this planning and scheduling, is more or less applicable during the construction as well. Okay. However, in addition, during the construction, you can also the planning and scheduling can enable the manager to prepare a checklist of key dates, activities, resources, and so on. Okay. Once although you can establish the key dates and activities even before the planning and scheduling, but in essence, the schedules keep developing. Plans are kept to be refined with the passage of time. So therefore, you can establish the new key dates during the construction. These key in planning and scheduling terms, these key dates are also called as the milestones. There can be some new activities which may occur during the construction phase of the project, which earlier could not have been established before the construction. The reason is because before these the reason is because construction is a very complex business. Construction project are quite complex, so we can only know the real picture when we go into the actual construction. Okay, before going into the actual construction, we do not have any refined idea about the construction processes. So therefore, we may new activities and new key dates for the construction project can be added, are needed to be added, or which may these new dates or activities may suddenly are revealed to the project personnel during the construction as well. So of course, the planning and scheduling, if has been done before, and which have the previous planning and scheduling which has been done before is connected with the current planning and scheduling, then it is very easy to integrate the new activities and new dates and new resources into the project. Okay. It provides a means for evaluating the effect of changes and delays. Okay. So whatever changes are happening in the construction project, it provides a basis for that to incorporate those changes. So it is also quite obvious because changes in the construction project are quite common. Okay, there are separate topics, separate chapters in the book, or even the whole books on how to manage the changes in the construction project. So changes in the construction project, either it is if they result from the contractor side or from the owner side, or even sometimes by the designer or the architect side, they are very important. So if there is a proper plan and schedule established in the project, then incorporating those changes becomes relatively easier and more systematic. The planning and scheduling serves as the basis for evaluating progress. So progress evaluation. So it is obvious, for example, if we have already established a plan before the construction, we have a baseline already established. Later on, when the construction has taken place, I mean, a normal construction project, for example, a building normally takes like 1 year, 2 years already, so which is an appreciable duration. During that construction project, some of the work is taking place on the construction, and then that work is compared with what was originally planned. So we can evaluate the progress. Okay, so what has been done and what was supposed to be done, these two works are compared to evaluate the progress. And it also helps or aids in the coordination of resources. Okay, coordination of resources. So coordination of resources means, for example, certain resources, personnel resources, human resources are very important. So normally in a construction project, a construction company may have several other tasks taking place at the same time, several other projects taking place at the same time. So if one engineer who has some specialty in certain kind of work is needed on that project, and at the same time, that engineer is also needed on another type of project. So there will be a problem. There will be a time conflict. Okay. However, if a proper planning and scheduling has been done, then those scarce resources can be assigned to different projects accordingly. Okay, so it helps in. This is one of the example of the aiding the construction coordination of resources. After completion of the construction, what is the purpose of the planning and scheduling? It permits a review and analysis of the project as actually carried out. So this is important. Normally, this type of task is not taken very seriously, but for successful construction companies, they do these tasks. They do this type of task very in a serious manner. For example, the reason is because for a construction company not only has to complete just one product, they have to perform several projects in the future. So the lessons learned from the previous project, which also include the planning and scheduling lessons, they need to be, these lessons need to be captured, and these lessons learned should be used in the future projects. And one of the example for these lessons learned is the establishment of the schedules for the future project. In the past, if certain activity has taken say like 3 weeks, so it may be more likely that a similar activity in a new project may take proportionately the same time depending on the size of the project. Okay, so the duration of the activities, the resources used on the activities, that type of information, if it is captured from the previous project, can be useful for the future projects as well. And lastly, it provides historical data for improving future planning and estimating. Actually, I was talking about same thing as well. Okay, it permits a review, and then it will be helpful for the future improvement of the planning and scheduling. So this was the introduction to the planning and scheduling, and which has told that what is the purpose of planning and scheduling before starting, during construction, and the after completion of construction. I kept on speaking, but let me see what, do you have any questions? Do you want to ask anything?
Yes. Is there any difference between checklist and evaluation?
Checklist are some of the items which needs to be just checked. That means, for example, if that work has been completed or not. Okay. Or the other thing is, you said as the evaluation. Evaluation is a process, okay, by which we will look at certain parameters of certain work, and then you will compare its performance. Okay, so checklist is more or less like in this case, you say that it is completed or not completed. But in evaluation, maybe you will take some percentage progress or kind of this. Of percentage progress of the work.
Thank you. Now it's clear.
All right, so let's move ahead. So in this topic, then I will talk about these scheduling methods as well. Okay, but for to apply any type of scheduling, let's learn some of the principles first. Okay, so there are a number of different forms of schedules are there. Okay, first thing you need to understand is there are a number of different forms of schedule. There are some written schedules, that bar graph schedules, network schedules, and of course there are some other as well. But most common schedules in the construction management or in any other projects are the bar schedules and the network schedules. So therefore, we will only consider about the bar graph, network schedules, and another part type, which is called as the linear scheduling method. So what are the scheduling principles? It first of all, establish a logical sequence of operation. Okay, so certain activities can only if there are if there are more than two or more activities, there may be a logical sequence between those activities. So for example, you can take the example in a construction management. I often take the example of the concreting. Okay, so when you want to pour a concrete, so there are certain activities which must be performed in a sequence. So first of all, if the pouring of the concrete is for a slab, so for that slab, there should be a formwork first, and then there should be a reinforcement or the steel bars that should be placed there after that. And then there should be a concrete pouring. And then after concrete pouring, there should be a curing of the concrete. Okay, so you need to follow this sequence of the work. So we cannot pour the concrete before pouring the formwork. So there will be a logical sequence of operations. Do not exceed the capabilities of the resources that are available. So this is another principle, because a schedule without establishing, without the consideration of the resource is not a schedule. Okay, a schedule without the consideration of the resource is not a schedule. Okay, so once there is because it will be the schedule that will be that will assign the resource. Okay, that what I am saying is that it will be the resource. It will be the resource that will drive the schedule. Okay. Provide for the continuity of operations. Okay, that means operations when certain operations or the activities are being scheduled, those activities should be placed in a more or less in the logical sequence, and then those resources should be provided for the continuity of the operations. Okay, adequate amount of resources should be provided. And the start project controlling activities early. So there will be a number of activities on the project. Some of the activities will be the critical activities, some of the activities will be the non-critical activities. Critical activities will be those activities, if they are delayed, they will delay the project. So more focus should be placed on the critical activities, because if these activities are delayed, the project will be delayed. So there are some other activities which are called as the non-critical activities. Those non-critical activities are also important, provided if there are some resource constraints. Okay, scheduling principles, accuracy or validity of scheduling depends on the validity of the work quantity and productivity estimates used. It means that whatever the estimates which are used in your project activities, the accuracy of those estimates is very important. So, for example, if an activity has been estimated to take place, has been estimated to take like 14 days to complete. That means like 2 weeks, or if we consider the 5-day week, then maybe 10 days to complete. If an activity takes 10 days to complete, and if then we must be sure that establishment of 10 days has been done in a accurate manner. The estimates are never very accurate, but the accuracy as high, the accuracy which can be taken into the project, that is helpful. Okay, so the accuracy of an estimate of time it will take to perform a construction operation is a function of the kind of work involved and prior experience in doing that sort of. So how does this accuracy come from? It depends on the type of work and the prior experience in doing that sort of work. So the example is, one expects a more accurate estimate of the time required to install a wastewater line in a residential structure than of the time required to install a cooling line in a nuclear power plant. So you can see that a nuclear power plant project is a very complex project, very much complex project compared with the residential project. So if the same type of activity is performed in the residential project, and on the other hand, in a nuclear power plant project, so it is much more, the estimate for this activity would be much higher in a residential project, because that is a relatively simple project than in nuclear power plant project. So the type of the project, and the planner have a thorough understanding of the nature of the work to be performed and the relationship between the various work items making up the progress. So it is the job of the planner to estimate the duration of the activities. So a very experienced planners and schedulers or estimators are needed on the construction project, who can establish the duration or can estimate the resources needed for that activity much accurately. So the experience of the planner is very important. And that is what activities must be started or completed before other activities can be started or completed. Okay, so that means this here we are talking again about the logical sequence of the activities. So with this thing in mind, so we can now look at certain methods for the for representing the plans and schedules. So one of the most basic method is the bar graph schedule method. So the bar graph or the bar chart schedule is a graphical schedule relating the progress of items of works to a time schedule.
I'm sorry for interrupting you. Can you show a photo maybe of this schedule in order to imagine and understand better?
I will show it. You mean the photo of what?
How it looks like, this bar graph schedule.
Yeah, I have just started it actually, bar graph, and then in the following slide, I will show it.
Okay. Can you show it before description, if it's possible?
Just wait a minute. Okay, so just give me a second, okay? I'm getting one call. I think it's recording now. Yeah. Okay. I will show the bar chart schedule, but let me read some of this text first. So the bar schedule is originally was developed by the Henry Gantt. So that's why it is normally called as the Gantt chart. Okay. The bar graph schedule is the very widely used schedule found in the construction work. Its continued popularity is due to its very graphic and easily understood format. Okay, so a sample bar chart has been shown in this figure. Okay, so as you can see that this is the bar chart which is shown over here. So this is how a bar chart looks like. Well, this is not the only representation of a bar chart. You can have some other representation of the bar chart, which may slightly be different than this, because in this case, the bar chart has been shown in a manner in which we are also showing the actual progress on the activities as well. Okay, so first of all, what is a bar chart? So as you can see that in the bar chart, we have certain activities in the project, and those activities in the project are represented by horizontal bars. So here in this case, if you can see that the dark black bars are showing the activities. Okay, so a simple project of about 5 activities has been shown over here, and their names have been shown on this over here. Okay, so it is clear and grub, drainage. Okay, then it is subgrade, base course, and pavement. So this is a road construction project. Okay, this bar chart has been shown for a road construction project, and these activities are performed in a sequence. Clear and grub, clearing work is performed before. So construction of a runway. Okay, yeah. So some horizontal project has been shown over here, and then drainage is established. Then subgrade is made. After that, there is a base course which is installed, and after the installation of the base course, the upper pavement is installed. Okay, so you can see that for each operation, okay, operation, or we are using the word operation for normal term activity. Okay, over here. For each operation, we are showing over here 2 bars. Okay, one is for the scheduled, as represented by SCH, and the other is for HCT. The other is for the actual. Okay, so this means that if this project has already started, okay, this means that this project has already started, which that means when some project has already started, then there is only then there will be an actual progress on the schedule, or there will be no progress in a planned schedule. So in by using this bar chart, we can see the progress on the work. Okay, so it shows that this bar chart shows that the time dimension is on this upper part of this table in weeks. It shows that this clear and grub activity will take 3 weeks to complete. Okay, by the end of first week, there is this letter number over here, 20. 20% of the work will be completed. 20%. And by the end of second week, 70% of the work will be completed. And by the end of the third week, the remaining 30% of the work will be completed. So that means the progress will be 100%. But in actual, what has happened was that by the end of first week, this work was not started. But by the end of second week, 45% work was completed. By the end of third week, 90% of the work was completed. Okay. So in this way, you can read this bar chart over here. There are two additional columns over here. This shows the hours and this shows the percentage weight. So hours means this will mean that this activity will take 750 hours to complete. Okay, and this activity will take 150 hours. And similarly, the time estimates for each of these activities and operations have been made. And then when time estimate has been added up, and then what is the percentage of the time estimate for this clear and grub activity? 4.7%. Okay. For drainage, the time estimate is 0.9%. Most of the work is for subgrade, base course, and the pavement activities at 26.4, 25.2, and 42.8% of the effort. Okay. So this is all the information. This is how all the information you can read from this bar graph. Okay. So as an example, yes.
Can I ask one thing from the chart? Yeah. So those numbers above bar graphs,
yes.
Bar blocks, let's say. So means the percentage, right?
Yes, percentage
of the
work
done. Yeah. So that means, for example, the first activity, how is it called? I don't see
scheduled.
that.
SCH is the scheduled.
No,
and
I mean
ACT,
the first activity. Just
yeah,
first
clear
activity.
and grub. Clear and grub.
Yeah. So that activity is not finished yet.
That activity is not finished.
Last number is 90%. Yeah.
Yes.
So it needs to be continued, right?
Yes, it will be completed later on. Yes, it's only completed 90%. And yeah, one thing I forgot to mention about is that this bar graph, which is shown over here, is not for the completed project. It is for the progress, the project which is in the progress. Okay, as you can see that only the first 3 activities have shown some progress, right? But the last 2 activities have not yet started because there is no actual shown over here. Okay. So, for example,
for the fifth activity, sorry to interrupt. I wanted to ask about the fifth activity. For example, it is scheduled, but not till the 100%, right? How's it?
Which activity?
Fifth one, the last one.
Yes, fifth one has been scheduled but has not yet started.
Yeah, I know, but the number, the percentage, 95% at the end of the block. So, is it at the right end of the block?
It is here. It is here. Yeah, it is here.
Ah, okay, thanks.
Yeah, 95 is yes, here.
Yeah, I saw that it is at the very end and just.
Yes.
Okay, sorry.
Yes. Okay, so this is just showing and giving you a snapshot of the progress of the project. Okay. So using this bar graph, then we can calculate the cumulative project progress. Okay, so before this bar graph, there were 2 slides, but more or less this is the same thing which I mentioned in the word. So I will skip these 2 slides. Okay. And now what information we can establish from this bar graph, that will be the cumulative project progress. Okay, so this cumulative project progress can be established in the form of this curve. Okay, in the form of this curve. So what this curve shows, that the overall work completed on the project as a passage of time. So it will show that as at the end of the first week, this much amount of work. So it's about, I don't know, maybe 2% work has been completed. At the end of 2 weeks, about 10% or 9% work is completed. At the end of 3 weeks, about 15 to 16% work is completed. And then the work shoots up, okay? Then the work is taking place at a very higher pace. And in the end, the pace of the work again decreases. So we can get this curve for every project if we can measure the progress of the project. However, this curve has been obtained using this bar chart. Okay, using this bar chart, and the formula used for this is formula number 1. Okay, it is the sum of the products. Okay, so you multiply the activity progress with its weight. So you do it for all activities. You do it for all activities, and then some of those products you take, and then you can measure the progress. So for example, end of first week, at the end of first week, the progress is 0.9%. How this was obtained? For this week, we'll go back to this first chart. At the end of the first week, we can see that at the end of the first week over here, there is only this first activity. Okay. And there is only this first activity. And this activity is was scheduled to be 20% complete, right? This activity was scheduled to be 20% complete, and this 20% of this 20% and this the overall of this activity is 4.7% of the whole project. So 20% of 4.7% is the overall progress of this project. So 20% of this 4.7% is 0.9%. So that means the overall progress on the project is 0.9% at the end of the first week. But here, if you see that at the end of the second week, it is 0.7 times 4.7 plus 0.6 times 0.9. And this has come from activity 1, activity 2, and activity 3. Okay, 0.15 times 26.4. And the overall progress is 7.8%. So we can also see it from here. So if you see the picture at the end of the second week, that means over here. Okay, can you see my cursor? This cursor over here. Okay, at the end of this line. So for activity 1, it is 70%. Okay, 70% multiplied by 4.7, 0.7 multiplied by 4.7. So this is what has been done over here, 0.7 multiplied by 4.7. And for second operation, drainage, it is supposed to be 60% complete. So 60%, 0.6 multiplied by 0.9, 0.6 multiplied by 0.9. So 0.6 multiplied by 0.9. Okay, and for over here subgrade, for subgrade it is 15%. Okay, 15% multiplied by 26.4, 0.15 multiplied by 26.4. So 0.15 multiplied by 26.4. So if you add up all together, 7.8%. So it means that the cumulative project progress is planned to be 7.8% and by the end of second week. Okay, so these by these calculations we got the first 2 points of these curves. So by the end of first week 0.9%, by the end of second week 7.8%. And similarly we can get all the other points. Okay, 3, 4, 5, 6, 7, 8 from this, and then you can repeat the same calculation for the end of the third week and for other calculations. And then when you plot these points, we get this curve. Okay, is it clear at this point?
So these are all expectations, right? I mean, we are focusing on the scheduled part of the bar graph.
Yes, scheduled part.
So do we do these calculations for actual one too?
Yeah, yes, we also do it. So for the given information like this, we can do it. Yeah, we can also do it. So for example, what was the actual progress by the end of the first week, or like that? Okay, we can also do it.
Okay, thanks.
So in this case, you can see that in a very simple bar graph, you can get a very detailed overall picture of the project. Okay, so that was the cumulative project progress. Okay, end of the first week, end of the second week, end of the third week. So I think I have already explained it. Okay, and then of course this curve can even be expanded to show the actual progresses. So in this case, as the information has been given, we can only establish the actual progress by the end of the third week only, because other information has not been given. Because so it means that we are taking the status of this project by the end of third week. Okay, by the end of third week. Okay, so that is the bar graph. Then we have is the yeah, this is another one. So this is just the combination of the previous two pictures. Okay, so here we can also see that we can also superimpose the bar graph with the cumulative time curve as well. So we can show both on the same page as well. So that means instead of looking at the two separate pictures, we can have both type of graphs. That means the bar graph and the cumulative progress curve on the same page. So this gives us the cumulative picture. Okay, so the normal progress curve. So this progress curve, which we have shown over here, you can see that the shape of this curve is very important, and from a large number of construction projects, from a large number of construction projects, many of those construction projects results in this type of curve. Okay, results in this type of curve. So the probable shape of the cumulative progress versus time curve is shown in this figure 4. Okay, it's shown in figure 4. And the progress is slow at the beginning of the project as the work is organized and the workers become familiar with the assignment and the procedures. So as you can see that the progress is slow at the beginning because workers are coming on the project, they are becoming familiar with the project, so the progress is slow. Only about 15% of the project is completed in the first 25% of the time. So in the first 25% of the time, you can see that only about 15% of the work is completed. Okay, remember that these are not very fixed figures. Okay, so we are describing this curve qualitatively. Okay, so in another project, in the first 25% of the time, it may happen that the work is only completed 10%, or the work may be completed like 20%. But qualitatively, the shape of the curve will be similar. Okay, so we are describing it qualitatively. So after that, the progress is made at a rather constant rate until 85% of the work is completed at the end of the 75% of the project. So that means in the middle period, the work the work progress is usually much higher than the linear increase in the time. So we can say that about 85% of the work completes in 75% of the time. And in the last 25% of the time, the progress again goes down because as the work is finished, some of the demobilization activities takes place. That means we are moving out of the project. Some of the finishing works are relatively slower than the original main structural works. So the progress again becomes slow at the end of the project. So this type of curve is called as the normal progress curve or an S curve, because the shape of this curve, is similar to an English letter S. So for example, if you take S and then you can elongate it on both sides. So that will be the shape. Okay. So therefore we call it as an S curve. Okay. It generally applies to any type of non-repetitive work. Okay. If the work on the project is non-repetitive, it generally will apply. So this type of shape will apply. However, there can be certain exceptions as well. Okay, so if the shape of a scheduled cumulative progress curve deviates substantially from the curve of the figure 4, we should carefully investigate this reason. Okay, so there can be certain exceptions. So for example, some of the items in the project may be quite expensive. Okay, so if we are measuring the progress with respect to the dollar amount, then there can be certain items in the project which may be quite expensive, and then those items may, if they will be installed those items, if the bill is received, so then the shape of this S curve may deviate. So otherwise, if there is no such situation, then we may suspect that there may be some mistake, and so that the shape of this curve to investigate that why this shape of the curve is not in the form of an S curve. Okay, so otherwise it is likely that a mistake has been happened and that the planned rate of progress is unrealistic. So this shape of the curve, this S shape of the progress curve, cumulative progress curve, is a kind of like a fundamental shape for the construction project. Okay. So this was about the bar chart and their use. Do you have any question? Do you want to ask any question about this bar charts? Next, we are going to start the network method.
I have a question. How do we indicate prerequisites on this bar chart? If one work should be done before other?
I don't understand. What do you mean by the prerequisites?
For instance, if one work should be done before another, must be done.
Yes. Okay. Yeah, that is very. Now I understand. What do you mean? The prerequisite means the predecessors or the relationships between the activities. Yes, it can be shown, but for example, in here over here. Prerequisites, that means what you say is the prerequisite means that which activity will start after which activity. So these relationship lines can be shown by the arrow. So for example, if you take the arrow from here and then move to here, and then this can be shown. Okay, so this can be shown, okay, over here. But generally, these relationships are not shown on the bar chart, because if those relationships are shown on the bar chart, then it becomes very difficult to read. Then bar chart becomes very difficult to read. So in the plan projects, Microsoft project, and in the Primavera P6, there is an option to show and hide those relationship lines relationship arrows between the bars. So sometimes if the bar chart is not that complicated, those relationship lines can be shown. But if there are so many different bars, then showing all the lines make it a very cumbersome to read. So it can be shown.
Okay, thank you. I understood now.
Yeah. So the short answer is generally it can be shown, but bar chart are not very convenient to use if these are shown. Okay, so next is the critical path method. In that we have these several of these topics. And first of those topics is the deficiency in the bar chart, bar graph schedule, and this is the deficiency which I have just described. So bar chart is not very useful to show the relationships between the project activities. Okay, so I mean, some of one you have answered. You have said it as prerequisite. So it is the relationship between the project activities. So failure to identify those activities which actually control the duration. So bar graphs also cannot show those activities which drive the project. Although I will not say they cannot show it, we can show it. And Microsoft project or Primavera P6, they can also show it as well. However, normally it is very difficult to maintain it. Okay, we can show it at one time, but if we want to revise it, then you have to revise it from the beginning, okay, to show them again. So they can be shown, but it is difficult to maintain and keep showing it on a consistent basis. Such duration controlling activities are called critical activities. So those activities which, if they are delayed, then they will delay the whole project. The bar graph schedule also fails to show the effect of delay or change in one activity on the entire project. So although it is also possible, but we have to look into much details and provide much more effort in a manual calculations to show that if one activity is delayed, then which other activity will be delayed. So for example, if I go back to this original bar chart over here, so since over here we are not showing any relationship between those activities, okay? So we don't know that if we, for example, if I delayed this activity, what effect it will have on this activity, okay? This is not very clear from this bar chart. Okay, this is no, although this is a kind of this is a linear project, which is slightly different from those projects which are which do not have the repetitive activities. Here we have certain activities. These activities are going in more or less parallel with each other. So that means some part of the previous activity is finished, then we can start the next activity. But even in the non-repetitive type of projects, it is difficult to understand the effect. Although it is possible, okay? Although it is possible, but it is difficult that we can show the effect of delay or change in one activity on the entire project. The development of the network planning methods was done in 1957 to 1958. And as a result, a method called as the critical path method was developed jointly by the DuPont and Remington Rand companies as a method for planning and scheduling plant maintenance and construction projects utilizing computers. So the critical path method, which we know now, was developed in 1957 to 1958 in those years, and certain by these two companies who used it for their internal projects. In parallel to that, almost at the same time, another method which is called as the program evaluation and review technique was also developed. So CPM and program evaluation and review techniques were the two earlier network-based methods. Okay. So both use the network diagram to graphically represent a major activities of a project and to show the relationship between these activities. So the major difference between the CPM and the PERT is that PERT utilizes probability concepts to deal with the uncertainty associated with the activity time estimates, whereas the CPM assigns each activity a single fixed duration. Both CPM and PERT are network methods, but CPM is more popular in the construction projects. PERT is normally useful for more like a research and development kind of projects where there is a big uncertainty about the time duration of the activities. So it assigns some probabilities to the duration of the activities to ascertain that what will be the probability of completing the project in a certain amount of time. So if there is a less amount of certainty in the project, if the project is relatively conventional, such as a construction project, so a critical path method is used because critical path method uses a single fixed duration, whereas the PERT uses 3 time durations: pessimistic time, optimistic time, and the most likely time for the duration of the activities. So in this chapter, critical path method has been explained. The network diagram. So the network diagram is shown by the 2 approaches. Okay. So let's for starting the network diagram. So what is a network diagram? Network diagram is a diagram to represent the activities on the project. Okay, and what are the activities on the project and what is the project? So a project, for example, a construction project, construction of a high-rise building, construction of a 2-story residential building, okay, like that, okay. So that just take the example of a 2-story construction building, okay. Construction of a 2-story building. So there will be certain a number of activities. Some of the activities will be related with the foundation. Some of the activities will be related with the superstructure. Okay, some of the activities will be related with the internal architecture. Okay, finishing activities. So a construction project, say about 2-story high residential building, may have like close to 100 different activities. So we will represent a project by the activities. So once we represent the project by the activities, we also will know that certain activities will take place only when certain other activities will be completed. Okay, so we will have the activities. However, we know that although we know that the scheduling in scheduling, the reinforcement reinforcement in the slabs can only be placed after the formwork has been completed. The pouring of the concrete can only be placed after the formwork and the reinforcement has been completed. So we know certain kind of logical relationships between the activities. So using those logical relationships between the activities, we can represent those activities in some sort of form. Okay. So there are 2 approaches for representing those activities. One is the activity on arrow network approach, and the other is the activity on node network approach. Okay, so in this figure over here, as you can see, can you see this figure?
Yes.
Yeah, in this figure, you can see an arrow. So this arrow is shown by an activity description, which is called as the move-in activity. Okay, so something that means for moving in to certain part. So this is an activity. Okay, And this activity has been represented by this arrow. So you can see that the arrow has a direction. So in the activity on arrow method, we show arrows pointing from the left to the right. Okay, so this is a convention which is used. There is a number over here, one which is shown over here, which is called as the activity duration. And at the ends of the arrows, you can see two circles. And within these two circles, there are two numbers, two-digit numbers. So what these numbers show the events. Okay, so this is the beginning event. That means which is the number at the tail of the arrow. It is the beginning event, and this circle at the end of the arrow will show the ending event. So these circles will only show the beginning and the end of the activity. So this is the notation which is used in the activity on arrow network method of the scheduling. So let me show you the figure. Okay, I think there are certain descriptions which have been given on these slides, but it is better for me to show all those descriptions in the form of a network. So you can see now figure 16.6 from the book. And this figure shows a small project. So you can see that there are certain arrows, you can see, and then there are certain circles. At the end of each arrows, there are circles. So you can see that this beginning event of this activity drill well, okay, drilling, that is a drilling process for the well, starts from event 1 and finishes at event 2. Okay, and drilling process of the well takes 4 time units, maybe days, maybe weeks. Okay, let's say a drilling of the well takes 4 days to complete. So once the drilling of the well is done, then a pump house can be constructed. Okay, then pump house can be constructed, or pump house can be installed in, say, about 3 days or 3 weeks. Okay, if you take drilling of the well in like 4 weeks, pumping a pump house will take like 3 weeks. But at the same time, when you are drilling the well, okay, you can also start constructing the power line. Okay, we can also start constructing the power line. So it means that drilling of the well and the constructing of the power line are these two activities which can take place simultaneously. And at the same time, excavation activity also take place. And at the same time, the delivering of the material activity can also take place. So you can see that at event 1, several of the activities are starting. Okay, at activity 1, several of the activities are starting. So now you can see the logical relationships between the activities. Okay, over here. Let's move to here, over here, or maybe here. Okay, installation of the pipe. Here you can see that the installation of the pipe can only be done when excavation is completed. Okay, so you can see that installation of the pipe can only be done when excavation is completed. Similarly, at the same time, foundation work can be constructed, but that foundation work can be constructed only when the excavation has been completed. Similarly, assembling of the tank can be constructed when the delivering of the material is completed. And this activity, erect tower and tank, can only be done when 2 previous activities, foundation and assemble tank, is completed. And then this last activity, install pump. Okay, can you tell me, install pump has how many activities which precede?
2. 3 activities actually. 3.
Yes, you are saying at 3 activities.
Yeah, it's going to start
pump
after
house,
drilling well.
construct power line,
Drilling well.
and
Drill well. Can you
no,
hear me?
immediate. I'm talking about the immediately preceding activities.
Immediately, or just pump house and construct power line.
Yeah.
But
Okay.
generally speaking, it should start after 3 activities. Yeah.
Okay. Let me say, because here you can see there is this dashed arrow as well. Okay. So these arrows are shown as the solid line, and there is only this one arrow which is shown as the dashed line. This dashed line arrow is called as the dummy activity. So this dummy activity is needed to show that, because in this case, installation of the pump can only start after the pump house is completed. So for this installation of the pump, we don't have to say that it will only start after the drill well. This is understood, okay? Because only pump house will only start after when the drill well is completed. So for the installation of the pump, we don't need to say that the drill well will be completed. So the installation of the pump, we will say that pump house is completed, construct power line is completed, and due to this dummy activity, excavation work have also need to be completed. So the installation of the pump has 3 predecessor activities: pump house, construct power line, and the excavate. So this is called as the dummy activity. Okay. And yes, in this activity on arrow method, sometime we need to use this dummy activity to show the logical relationships between the activities. Without the use of these dummy activities, that logical relationship cannot be shown. Okay. Okay, so we have almost reached at the end of the lecture.
I have a question.
Yes.
I am a bit confused. What does numbers mean? Can you explain one more time?
Yeah, the numbers in the circles or the numbers?
Both of numbers in circles and
yes.
Below the line.
Okay, yes, definitely. The numbers in the circle are the event numbers. Okay, so these the purpose of showing these numbers in the circles is to identify the activities. So for example, this drill well activity can be identified as the activity 1, 2. Okay, so there is no other activity 1, 2 in this. Okay, if I say activity 1,
it's just for reference. Yes, this number.
yes, so for the identification purpose. Okay, and then the convention for these assigning these numbers is that we should increase the number from the left to right, or from the tail of the arrow to the head of the arrow. So the numbers should normally be increasing. And the other numbers are the shown over under the circle line, are the under the line of the arrow are the duration of the activity. So 4 weeks, 3 weeks, 3 weeks.
Thank you.
And there is one more thing about this dummy activity. So dummy activity, the use of dummy activity is only to show the logical relationship in the network. Dummy activities have no duration. Okay, that's why we did not show any number. But dummy activity can be shown by the 4, 5. That is the referencing by the identification purpose. Okay. So 1 and 2, these are the events. Okay, so every activity will have a beginning event and the ending event as well. Okay, so I think I have finished. I mean, have end up the time as well. Any other questions? Okay, so okay, we will continue this topic in the next class on Thursday. Thank you very much.
Bye. Thanks.
Thank you. Goodbye.
Goodbye.